Hello, it's me. I think somebody famous said that once. Okay, so we're going to do number 15. What does it say to do? It says factor each completely. Make sure to look out for common factors. Why is that? Because common factors can make your life so much easier if you just take them out of things. Um, so factoring, we want to find what are factors? It's two things that will multiply to be the original thing, two or more things. So we're looking for two pieces. Because this is an n squared, the most we could split that up would be to two linear pieces. And we're actually going to solve these as well. We're going to find out when is this thing going to be equal to 0, because that's usually an interesting point for us, or a point that we can find. So the first thing you're going to do, look out for common factors. Is there anything that we could divide each one of these pieces by? We're going to look to the smallest number, 7, because that's the biggest number we could divide it by. Can we divide the other things by 7? No. Can we divide 7 by anything else? No. So there are no common factors. We're just going to have to factor this old school way, which is to do 7 times 24, which is, I think, 168. And we need factors of 168. So our two numbers have to multiply to be 168, but they've got to add up to the middle number, which is 29. We're going to take both of those things into account. So I think that I know these numbers, but let's say that I didn't. The calculator can help me with that. There's a lot of ways you can do it. You can just say 168. What can I divide that by? I can divide that by 2. Oh, but 2 plus 84 isn't 29. You could do that. That's the time-consuming way, I think. But you can also hit y equals, type in 168 divided by x. And now every number, every xy pair is going to multiply to be 168. If you hit second and graph, it's just a list of factors of 168. Left and right, 2 times 84, 168. 3 times 56, 168. 4 times 42, you get the point. So we just have to go through our list until we find a row that adds up to 29. And it's like a game of warmer and colder. You see we're getting warmer, so it's 46. These 5 is not a factor of 168. 6 times 28, closer, that's 34. And now we've got 31. Bam, 8 times 21. So 8 times 21 does equal 168, but 8 plus 21 does also equal 29. So what do we do with those things? We bring them over here and we write them as linear factors. N plus 8 times n plus 21. But recall, factors should multiply to be the original. Is 8 times 21 going to get us this 24 over here? No. Is n times n going to get us 7n squared? No. What happened? What happened? We multiplied by 7. So we're going to divide our factors by 7 because they're 7 times too big. At least one of them is. And the one that's 7 times too big is that 21. 21 divided by 7 is 3. Okay, the other fraction, though, it doesn't simplify. And so what are we going to do? Bottoms up. 7 goes in front of the n. 7n plus 8 times n plus 3 is equal to 0. That thing is completely factored now. But what are the solutions? Well, one of the reasons we factor is so that we can find solutions to a problem like this. Because instead of trying to see all of this at once, we're breaking it down into smaller components that we can look at individually. Because if n has a value that makes n plus 3 equal to 0, so if n plus 3 is equal to 0, when does that happen? We can solve for that. It happens when n is negative 3. If I plug a negative 3 into this original equation, bam, it's going to pop out a 0. How do I know that? Because it doesn't matter what 7n plus 8 is. If this one's 0, I'm going to be multiplying 7n plus 8, whatever it is, times 0, which is 0. We know that immediately. The other answer is just going to be the opposite of this. It's going to be negative 8 over 7, and I can prove it to you. Set that equal to 0. Subtract 8 from both sides. 7n equals negative 8. Divide by 7. N equals negative 8 over 7. Bam. Ooh, I went circle on that one. Normally, no, not even normally. I can't deal with that. Okay, box. There's two answers, n equals -3, n equals -8/7, and then the factoring is also part of your answer. Okay, let's look at another similar problem. We're going to factor it, but it's a little different than number 15. Number 17. Number 16 is just like 15, except when you don't have to multiply by anything. So it's 7 times 24 here. It's 1 times -63 here, which doesn't change, -63. So this 16 is easier. 17 and 18 are kind of similar in that there's only two terms here. Okay, so can we factor it the same way? Yeah, kind of. But just like always, we're looking for greatest common factors first. Remember, look out for greatest or common factors. What are the common factors between 54 and 540? I bet 54. What are the common factors between x to the fourth and x to the third? There's 3 x's up in both of those. So those are things that we can pull out to the front and then say, we're multiplying both of our other terms by 54x to the third. So what do you have to multiply 54 by to get 54? 1. We don't have to write this 1. We could. I will. What do you multiply x to the third by to get x to the fourth? Just x. So the first term here is x. And then what do I have to multiply 54 by to get -540? You have to multiply it by -10. And then what do I have to multiply x cubed by to get x cubed? 1. It's already x cubed. So it would be 10 times 1. So this is factored now. Awesome. That was easier than the other factoring. At least generally speaking it is. So then what are the answers? You do the same thing we did before. We can take each of these factors, take 54x cubed, set it equal to 0 and solve, divide by 54, x cubed equals 0, x equals 0. That's a solution. If x is a common factor, 0 is a solution. And the other one, x minus 10 equals 0, add 10 to both sides, x equals 10 is a solution. Factors, solutions. All right, we're going to move into bonus coverage, which is number 18. Dun, da, da, da. 18 is a little, it's interesting. It's a good one, so let's go through it. Are there any common factors? I'll let you think about it. Yes. They can both divide by 4. 4 can come out here. Can we take out a variable? No, because this one doesn't have one. It doesn't, it's like, hey, I don't have a variable. It's not common. We don't have that. We don't share that. So 4 multiplies by what to get n squared? Or 4n squared? It multiplies by n squared. And then 324 divided by 4 is 81, n squared minus 81. So this has a common factor. However, are we done factoring? We still have an n squared here. We haven't broken it down into both of these. We could find the solutions like this. And if we found the solutions, we would also find the factors. Since this is bonus coverage, I'll do that real quick. If we add 81 to both sides, remember, if you see this, you can solve with inverse operations. Square root both sides. N equals plus or minus 9. If 9 and -9 are the answers, then the factors must be n plus 9 and n minus 9. If that doesn't make sense to you, even if it does, let's pause for a minute and let's look at it in the general factoring way. What is this function? N squared minus plus no n's. We're missing the middle term. So it might as well be written like this: n squared plus 0n minus 81. So what do we need? We need factors of 1 times -81, which is just -81. We need factors of that number that add up to 0. You're like, we can't do that. Sure we can. One has to be positive and one has to be negative, but they have to be the same number, because 9 times 9 makes 81. But -9 plus 9 is also 0. Kaboom. We bring them over here. N plus 9, n minus 9, 0. Kablamo. That's factored. You're rocking it. Keep going.